Let's take a look at some multiplication patterns. And these multiplication patterns are very important, especially when you are learning how to do matrix multiplication, because we are going to be trying to multiply a lot by tens and hundreds and thousands. So let's take a look at our first one. We obviously know the most basic multiplication, 1 times a number is going to equal that number. In this case, it's 1 times 6 equals 6. All right. Well, what happens if we bump this up to 60? Well, we know that that is going to be 60. Anytime you have a number times another number is going to be 60. 600, 6,000. But what happens if we go to 10? We change this to a 10. Well, this is going to become 60. But if we take a little bit closer look, we can see a little bit of a pattern emerging here. What we have essentially is we have 6 times 1, which equals 6, and then all we have to do is add the 0 in to make it 60. Well, let's see if the exact same principle applies here. This is 10 times 60. Well, if we do this, we go 6 times 1 is 6, and then we simply count the zeros, 1, 2. Our total is 600. And we can do the same thing here. 6 times 1 is 6, and then we just need to count the zeros, 1, 2, 3. 1, 2, 3. All right, here's some slightly larger numbers to work with to help illustrate what we just learned from our previous pattern. So in this case, we're going to start off by saying 1 times 52. Well, we know clearly that that answer is going to be 52. Well, using the exact same principle that we just learned, if we were to say 52 times 1, we would have 52, and then we count the 0, we actually have a total of 520. And 10 times 52 is, in fact, 520. Well, let's see if we can do this next one. We've got 10 times 520. Well, if we simply think, well, this is really saying 52 times 1, which is 52, and then we just need to count the zeros, and we have 2 zeros. And in this case, the number is 5,200. Well, now we have down here 5,200 times, or 100 times 5,200. Well, it's really like saying 52 times 1 is 52, and then we count the zeros. 1, 2, 3, 4. 1, 2, 3, 4. And our final tally is 520,000.